Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Abu Bakar and my number matrix is AA200191. We are from Group 3 and the question that we choose is question 2 for population and question 10 for Newton's law. So I will present the problem statements. For question 2 of population, the problem starts when we need to determine approximately how long radium will take for 1/2 of the origin amount to decompose. The information given, radium decompose at rate proportional to the quantity of radium present, and radium is found that in 30 years, approximately 1.32% of a certain quantity of radium has been decomposed. So the first problem statement we found is which chapter is involved to solve this question. So this question is in exponential growth and decay of the population chapter. Other than that, our group found other problems. That's it. What equation do we need to solve? We need to use when solving this population question. So one of the equation that we can use is the x per dt equal to negative kx, where the x per dt is rate of decomposition of radium. Finally, another problem that we found out is what is the concept that must be applied regarding exponential growth and decay differential equation. For question 10 of Newton's law, we need to find the thermometer reading after 6 minutes outside. The first information given is the thermometer reading inside a house is 70 Fahrenheit and the outside air temperature is 10 Fahrenheit. After 3 minutes later, the thermometer reading is 25 Fahrenheit. This means the thermometer reading drop when it changes places of different temperatures. So this is a cooling phenomenon in a certain period of time. So the first problem statement we found is what chapter is involved when we solve the integral question that are related to cooling. The chapter we can refer is Newton's law. So next problem statement that we found is what equation we need to use to solve this question. G1 of the equation that we can use to solve this question is dt per dt equal to minus k bracket t minus ta. Last but not least, another problem that we found out is which area is considered in application of Newton's law of cooling.
Assalamualaikum, my name is Muhammad Ali Berani. My metric number is AA200324. So, I will discuss about the filler table for the question 2. For the question 2, it is found out that is 13 years 1.32% of a certain amount of the radium decomposed in the air at the rate proportion to the amount of present. Determine approximately how long it will take for 1/2 of the origin amount to decompose. So the filler table we divide for the 3 main point, which is facts, idea and learning issue. For the facts, we identify and point out the 3 facts that can be found. The first is radium decomposed at a rate proportional to the quantity of the radium present. Second, supposedly it is found that in 30 years approximately 1.32% of a contained quantity of the radium has been decomposed. Number 3 is assumption is made how long it will take for 1/2 of the origin amount to decompose. So for the idea, we have found that three ideas that we found out. The first is The statement radium decomposed at the rate proportion to the quantity of radium represent the expedity which is the expedity equal to rate of decomposition of radium. Second, the given word problem is about the decomposition of a substance in a contained period of time. Then contrast with exponential growth. Number 3 is the sign for the constant of proportionality is negative since it's a decomposition the process of an exponential decay. If it an exponential growth, then the sign is positive. Since it is a decomposition process, the first question is most probably to be used the expedity equal to negative kx. For the learning issue, there are 3 learning issues that we can point out. The first is what chapter is involved when we solving differential equation question that are related to decay. Second, what concept must be applied in solving differential equation that are related to exponential growth and decay. Second, what is the concept that must be applied regarding exponential growth and decay. Number 4, and lastly is how does the differential equation relate with the exponential growth and decay formula in order to obtain the final answer. That's all from me. We give to the next presenter. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and greeting everyone. My name is Amirul Shazwan Amali bin Jamaluddin and my matrix number is AA200277. Today I'm going to show you the fill-out table for question 10. A thermometer which has been at the reading of 70 degree Fahrenheit inside a house is placed outside where the air temperature is 10 degree Fahrenheit. 3 minutes later, it is found that the thermometer reading is 25 degree Fahrenheit. Find the thermometer reading after 6 minutes. To start off, F stands for facts, and there are 3 facts that we found from this question, which is 1. Thermometer reading drops when it changes place of different temperature. 2. 70 degree Fahrenheit of the thermometer inside the house drops to 25 degree Fahrenheit in 3 minutes when it is moved to the outside. 3. Assumption is made for the thermometer reading after 6 minutes. Then I, which stands for ideas. There are 3 ideas in total for this question. 1. Heat will be transferred to the surrounding area as the time taken increases. Heat naturally flows in one direction only, which is from hot to cold areas. 2. The difference between the temperature from inside the house and outside is 45 degrees Fahrenheit. Obviously, this is a cooling phenomenon in a certain period of time. 3. The temperature of a body changes at a rate proportional to the difference in temperature between its own temperature and the surroundings. The process involved in cooling, so it will be negative because the temperature will be dropped. The equation is d capital letter T per dt equal to negative kx. The K symbol is for temperature in physics. After that, we have L, which stands for learning issue. 1. What chapter is involved when we solve the integral question that are related to cooling? 2. What does Newton's law of cooling depend on? 3. Which area is considered in application of Newton's law of cooling? 4. How can the concept and calculation help to solve this equation? Lastly, A stands for action plan or resources need. Firstly, we need to search on the internet for getting more information and for the formula that will be used for the equation, and to discuss with the team members. That's all from me, thank you.
Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Muhammad Akmal bin Abdul Halim, matrix number AA200308. Alright, so today I'll be explaining regarding the solution for question number 2 based on the problem-based learning. So, what is question number 2? So before I start, I'll be reading out the question. So the question number 2 starts with, I'll read out the question out loud. So it is found that in 30 years, 1.32% of a certain amount of radium decomposes in the air at the rate proportional to the amount present. So now the question asks, determine approximately how long it will take for 1/2 of the original amount to decompose. Alright, so right now, from the previous explanation which my friend have already given, based on the filler table for question number 2, I hope you already have a rough idea on the ideas or the problem that you may face when solving out this question. So without wasting any more time, I will teach you on how to solve the question number 2.
Alright, so right now for the equation dx dt is equals to negative kx. So what is dx dt? dx dt is the rate of decomposition of radium. X is the amount of radium at time t, and x0 is the initial amount of radium at time t is equals to 0. So now from the equation, dx dt is equals to kx. We make it dx dt, dx over x is equals to negative k dt. So for the first step, you integrate both sides. Integrate dx over x and integrate negative k dt. So once you integrate both sides, you're going to get in x, integrate of x, and you're going to equals to negative kt plus in c, integration of c. So after that, that's the first step. For the second step, you apply the inverse natural logarithm. So once applying the natural inverse logarithm, you're going to get x is equals to e to the power of negative kt plus in c. After that, x is equals to negative kt e to the power of integration of c, I and c. After that, you're going to get x is equals to ce to the power of negative kt. Alright, so right now, in order to solve for the value of c, we need to find we need to set a certain condition. So the condition is for x is equals to x0. This is when t is equals to 0. So keep that condition in your mind. So from the equation, x is equals to ce to the power of negative kt, by putting t is equal to x ce or negative k0. So from this, you're going to get x is equals to ce to the power of 0. On this, you're going to get c is equals to x0. So once you've come down to c is equals to x0, now you're going to substitute the value of c, since we already got the value of c in the initial formula. So what's the initial formula? X equals to ce to the power of negative kt. So still remember this formula. Now substitute the value of c. X equals to x0 e negative kt. So remember this value, we substitute right here. This substitute right here. Thus we got this. Now after we got this, we let t is equals to 30 years. Now why 30 years? Remember our question, we want to find for 30 years. So what do? X is equals to 100% minus 1.32%. Why 1.32%? This value we got from the question. The question, look back at the question and read. This value was obtained from the question. So from this, we press the calculator, we get 0.9868. 0.9868. Don't forget x0. Thus our value is this. After this step, we substitute the value of x. What do I mean by substituting the value of x? Simple. X is equals to x0 e to the power of negative kt. Remember this formula which we got from here? Yeah, 0.9868 is equals to x0 e negative 30k. So how do I get negative 30k? Remember, let t is equals to 30 years. So here we substitute t is equals to 30. Thus we got this. So right now, remember we got this value just now. So from this, we can write change its form simply. So negative 30k is equals to integration of n 0.9868 So from this, you can press this value in the calculator, IN 0.9868. You're gonna get a very long number. So negative 30k is equals to is equals to negative 0.01 0.0132 878 878 878 9433. So you press this value in calculator, you will get this. Once you get this, this is by using simple algebra, keeping the unknown right here. Negative 0.0132 878 9433 divided by negative 30. Thus you get your value of k is equals to 0.000449293. This is your value of k. So you can write your value of k in this form, or you can write it in standard notation, which is 4.4293 times 10 to the power negative 4. There's no problem in writing any of those two methods. This is your personal preference in which way. For me, I've transferred it in decimal form. So after this, still remember the formula that we use. X is equals to x0 e to the power of negative the 0.00000449293. Yep, this we substitute the value. Remember from the previous we got the value of k, we substitute it, we will get here. We got from here. So after this, we need to assume the value of x equals to 0.5. X equals to 0.5 x0. After that, the radium will decompose. So why do we make this assumption? So if you read back the question for number 2, it clearly states that if you read the last line, determine approximately how long it will take for 1/2 of the origin to decompose. Thus, from that came the assumption of x equals to 0.5 x0, then the radium will decompose. So after that, we'll get this x equals to x0 e to the power of negative 0.0044293 t. Then we've already made an assumption, which is x equals to 0.5. We put it here, 0.5 xo is equals to, copy back, x0 e to the power of negative 0.000449293 t. So once you got this form, you can actually transfer it, you can rewrite it in this manner. 0.5 is equals to e to the power of negative 0.000449293 t. So once you got in this form, you can straight away bring it over here, so which you will get negative 0.000449293 t is equals to this one, integration of 0.5. In 0.5, you can press this value in the calculator. However, I would like to recommend this step, since you have an unknown right here. So t is equals to integration of 0.5 divided by negative 0.000449293. I would recommend this step. So by doing this, you'll straight away get, you can press this value straight away in the calculator. You'll get negative 0.000449293. You get 15.64.913. So this is the answer. But however, you need to remember, we are finding the answer for t. In years, you can't have in decimal point. So why do I say so? So it's simple. We have 2013 to 2020, 100 years time in 1000 years time. So we can't have, for example, 1000.20 times. There's like no such thing. So thus, we can, from this, since we got the answer in decimal place, we can deduce that t is equals to 1565 years. So what's the answer? T is equals to 1565. Thus, this is your final answer, 1565 years. So with this, I hope you are all clear with all the steps. I would like to end my sharing session right now. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I will answer for the solution for question 10. Okay. For the first, we will use the dt over dt where the t, big T is for the temperature and the small t is for the time. So equal to negative k in the bracket upper bracket t minus dA and close the bracket. Okay, dA is for the temperature surrounding. Okay, after that, after we know that, we will put the TA, temperature surrounding, to the value of 10. Because in the question, he already said the temperature surrounding is 10 Fahrenheit. Okay, after that we will arrange the position where the temperature is on the left and the time is on the right. Okay, after that, we will integrate both equation. So it will be like this. Then to make it easier to we solve, so there is a ln at the left side, so we put the ln also in the right side. Okay, for this, okay, for the exponent, why the negative kt be the power, so it's like a logarithm concept. Okay. Okay, after that we will factorize the ln. So after that, we will cut the both ln, so it will be easier to us to solve it. So after that we got the t minus 10 equal to c exponent to the power of negative kt. Okay, we will simplify it into t equal to c e exponent to the power of negative kt plus 10. So back to the question, the question want to know what is the temperature at the time 6. So before that, we have to know what a value of for the c and the exponent negative kt. Okay, so let's find the c for this step. Okay, we assume the time is 0 and the temperature is 70 Fahrenheit. So we put the value to the it place, and then we will get the C is equal to 60. Okay, we got the C first. Okay, let's go to the next. Okay, next, after we get the C is equal to 60, so we go back to the equation where the t is equal to c exponent negative to the power of negative kt plus 10. Okay, so we put the c value where the 60, so like this. Okay, then we assume the t is equal to 3 minutes and the temperature is 25 Fahrenheit. Okay, after we solve it, and we got the exponent, we got the value exponent to the power of negative k, because the t is we know the value of the t is 3 minutes, so negative k like this. So la ilaha illallah. So after this step, we will go, after we got the exponent negative k value, so right now we got two information, that is c is equal to 60 and exponent to the power of a negative k is equal to 1 over 4 to the power of 1 over 3. So back to the question. We want to know what the value of temperature for that water after 6 minutes. So the time is 6 minutes. Okay, so we put it into the question, t equal to 6 exponent to the power of negative kt plus 10. So all the information we got, so just put it in the question, then we got the t. So the t is 13.75 Fahrenheit. That's all from me. Thank you.
Next, I will present the conclusion. For question 2, almost everything in our world grows and decays, from the growth of organism to their eventual death. from the growth of stars to their eventual supernovas, from the growth of crystal to the decay of radioactive isotope, and from the growth of animal population to the decay of radio signal. Plus, by implementing exponential and logarithmic function, we develop exponential and logarithmic function from a pure mathematical point of view, and we define this function rigorously and studied their properties, including derivative integrals. Thus, we take a more mathematical point of view for question 10. By applying differential equation to real life problem, we are able to solve it. Using the dx dt equal to negative kx bracket T minus TA, where TA is surrounding temperature. After that, we have to integrate both sides and get T equal to CE power to negative KT plus 10, and 10 is the air temperature. And next, to find C, we need to assume that T equal to 0, T equal to 70 Fahrenheit, and we get C equal to 60. The new equation also found that T equal to 60 e power to negative KT plus 10, where we replace C with 60. Right after that, use the information given, where 3 minutes later, it is found that the thermometer reading is 35 Fahrenheit. To find the E power bracket negative K, and we get E power to negative K is 1 per 4 power to 1 per 3. Finally, we can find the temperature after 6 minutes by using the equation and get the answer T equal to 13.75 Fahrenheit. So the temperature reading after 6 minutes is 13.75 Fahrenheit. I think that's all from our group. Thank you.